Hello students, I am Sunil Vaikunthe, one of the faculty members in physics, Angadi College, belagavi. I will take some questions based on Newton's laws of motion. Very first question: a block of 5 kg is resting on a frictionless plane. It is struck by a jet releasing water at a rate of 3 kg per second at a speed of 4 meter per second. Calculate the initial acceleration of the block. The data given here, the water jet releases the water at a rate means the mass per every second. It is 3 kg per second, and the water is going at a speed of 4 meter per second. V is not changing, V is fixed. Now by using the formula F is equal to dp by dt from the Newton's second law of motion, where force is time rate of change of momentum, where momentum is mass into velocity, d divided by dt into m into v. So here v is constant, take it outside. The dm by dt, the both values we know. This one is 4 and mass every second it is coming 3 kg. 4 3s are 12 Newton. Total 12 Newton force is acting on 5 kg mass. Now by using the same second law, we know that F is equal to m into a, mass into acceleration. There are the initial acceleration a. So a can be found out by taking the ratio of force to the mass. Force is 12 Newton, mass is 5 kg. So 5 1s are 5 2s are 2.5 4s are 2.4 meter per square second. So this is the initial acceleration in the block. Now let us see second example for this. Arrangement of two block system is as shown in the figure. The net force acting on 1 kg and 2 kg blocks are, they are asking what is the net force acting on 1 kg and 2 kg. And they are telling, assuming the surface to be frictionless surface, there is no force acting by the surface on the blocks. Now these two blocks are connected in and they are on the surface. There is a force of 6 Newton is acting on 1 kg. And this 6 Newton is making it to move to the right side, make it to apply the force on 2 kg. Let us take this force is here. And for every action there is equal and opposite reaction. That is the Newton's third law. For every action there is equal and opposite reaction. There is a force F acting. To find the force F, we need to find first what is the acceleration with which these two bodies are moving. Acceleration. The net mass is 1 plus 2 kg, 3 kg. So net force is 6 Newton. We can find out the acceleration by using the formula F is equal to mass into acceleration. Net mass is 3 kg. Acceleration we require, net force is 6 equal to 3a. This implies that a is equal to 6 by 3, that is 2 meter per square second. This is the acceleration. Now if I take the free body diagram of 1 kg and 2 kg, if I am taking only 2 kg, there is a force F only is acting. So free body diagram for second, mass m2. There is only one force is acting in this direction, that is F, which is making it to move with the acceleration a, that is 2 meter per square second. We know the mass, we know the acceleration, we can find out what is the force. So F is equal to mass m2 into acceleration a. So mass m2 is 2 kg, acceleration is 2 meter per square second. So force is 4 Newton, which is acting on second one. So here 4 Newton is there. Okay. We need to find out what is the net force on 1 kg also. 6 Newton in this direction, F Newton in opposite direction, that is 4 Newton. So net force on the first mass, if m1 is there, here in this direction there is a 6 Newton and in this direction, yeah, that is 4 Newton. Net acceleration will be in this direction with a. So 6 minus 4 is equal to mass into acceleration. Mass m1 into acceleration, where m1 is 1 kg, acceleration is 2. So answer will become 2. 2 Newton is the force. Or 6 minus 4 also we can take 2 Newton is the force. So on a first body it is 2 Newton, on a second body it is 4 Newton. So correct option is C. Thank you.
Hello my dear dear students, welcome you all for chemistry classes. I am Prasadam Palankar, working as a chemistry NEET and JEE faculty at Angadi College of Commerce and Science, Belgaum. Today in this session, we will discuss atomic structure, means structure of an atom, particularly Bohr's model of an atom. See, as you all know, the many scientists like J.J. Thomson, James Chadwick, E. Goldstein, Rutherford, Niels Bohr, Maxwell, there are so many scientists lagging behind with respect to identify the structure of atom. Where exactly this neutron, proton, electrons are located in an atom. Many scientists, after several research, they have given some assumption, they have given some conclusion. In that, we will discuss what is the Bohr's model of an atom. See, according to Niels Bohr, all the electrons are revolving around this particular nucleus in a fixed circular path. He called those circular paths are nothing but orbit. If an electron revolving around the nucleus in the first circular path, means first circular orbit, then it is a K shell, then n is equal to 1. If it is a second orbit, then L shell, n is equal to 2. If it is a third orbit, then M shell and so on. Right? K shell, L shell, M shell, N shell. See, according to Niels Bohr, all the electrons are revolving around the nucleus in a fixed circular path, and those circular paths are known as orbit. As long as electron remains in the same orbit, see here, I have mentioned, if it is the first orbit, then that is K shell. If it is the second orbit, L shell, M shell, N shell, and so on. If electron moving around the nucleus in the first orbit, then it is a K shell. As long as electron remains in the same orbit, it neither loses the energy nor gains the energy. Energy remains same. If electron jumps from higher energy level to lower energy level, means if second orbit to first orbit, or third orbit to second orbit, or fourth orbit to third orbit, then what happens? Electron jumps from higher energy level to lower energy. If electron jumps from higher energy to lower energy, then emission will take place. Electron jumps from higher energy to lower energy level, then emission will take place. Suppose electron jumps from lower energy level to higher energy level, means first orbit to second, or second orbit to third, or third orbit to fourth orbit, then absorption will take place. This change in energy can be calculated with the formula delta E is equal to E2 minus E1. See, according to Bohr's, the electron which is closer to this particular nucleus, the electron which is closer to the nucleus having smaller energy, and which is away from the nucleus will be having more energy. See, all these are what the postulates of the Bohr's theory. After Bohr's, we have Sommerfeld extension theory is there. In between that, Heisenberg tells that it is impossible to determine exactly position and momentum of an electron present in an atom. After that, actually, we have orbital concept, that is orbital, that is the three-dimensional region in the space where the probability of finding an electron is maximum.
Good morning, my dear students. I am Prasanna Surugan Nalgali, working as mathematics faculty in Angadi College, Reproduction. So now today we will discuss about the concept function. So let us discuss the definition of function now, and by giving some examples on it. So here I have defined the function as like this. Definition of function is, it is a relation between the two sets. So here we are going to relate the two sets. So in other words, we can define the function as every element of set A or associated with the elements of set B. So here the word uniquely is very important, because unique, that means there is a correspondence between one to one element. So here let me take one example on this function. Let us consider one domain here, that is capital A, and one codomain, that is capital B. Let us take some 3 elements in domain A and some 3 elements in codomain B. So let us have unique association. So element A in the set A is associated with element 1 in codomain, and similarly element B is associated with element 2, and element C is associated with element 3 in codomain. So in the other words, we can write this as f of element A is equal to 1, and f of element B is equal to 2, and f of C is equal to 3. This is the way of defining a function. Now let me give you an example which is not a function. Let us take one example here to illustrate the relation which is not a function. So let me take here 3 elements in set A, that is A, B, C, and 3 elements in set B, that is 1, 2, 3. So let us take association that first element of domain is A is associated with first element in codomain, that is 1, and second element in the domain is B. I am going to take 2 images for B, which is not possible in function, because the definition says function is defined as elements of set A are uniquely associated with elements of set B. Therefore here you can easily observe the element in set A, that is B, is having 2 images, means 2 association. Therefore it is not called as a function.
Good morning, students. Myself, Santosh Avagi. I am working as a biology lecturer and the NEET expert in Angadi PU Science and Commerce College, Belgaum. So today we will start with an interesting chapter, that is human reproduction. So before we start with this chapter, first we need to understand some of the concepts over here to understand this chapter in a better way. So first and foremost, as we know that reproduction is one of the prominent phase in every organisms where they are producing offsprings in order to continue their generations. So if you start with this actual concept, as you can see how a baby is developing in the mother's womb, and to understand this in a better way, we will see some basic concepts over here. Every organism that is involved in the reproduction process is producing the offsprings by contributing the maternal and the paternal gametes over there. Gametes are the components which is produced in the reproduction process from both maternal means mothers and the paternal means father gametes, which combines to produce the genetical recombination. This terminology is very important. Means genetical recombination means if any organism is produced from their parents, no doubt in that. But does it look like similar to their parents? No. They look, only few characters are carried from their parents, means that is what the genetic recombination. And this genetic recombinations with a new character, we call it as a variations. And these variations are very important for evolution, because in order to survive in upcoming any type of obstacles that is created by the atmosphere, means that is possible only with the new characters, and those characters are borrowed by this variations. And here you can see how the reproduction process is going to provide for their survival chances. Means only those species are fit and strong enough to fight this environmental obstacles, they will survive, and the remaining will get perished very easily. So for that, it is a slow process, and it's also a complex process. Complex process means more physiological activities are involved or the components are involved in this process, and even though as I specified earlier, it is also a slow process. Here you can take an example of the elephant where the gestation period is of 22 months. Gestation means the time period required for the offsprings to develop in their mother's womb. That is what we call as a gestation period. And this gestation period is going to give the successful, healthier young ones only in the favorable condition. Favorable condition means oxygen supply should be proper and the temperature should be in a favorable conditions, and every hormones that is required for their growth and development is up to the mark, means we consider it as a favorable